let's say you've got a right angle triangle here resting on a tabletop. Now, this angle here, let's say this angle here is theta, okay, and A is the adjacent, the length of the adjacent here, like this, okay. So you've got a right angle triangle resting on a tabletop. Now, hang on, let me rotate this thing here. So it's an exact same triangle, but I'm going to rotate it like this. Okay, bear with me. So I'm going to rotate it like this, and then put it down onto the tabletop. Hang on, let me tidy this up. So here it's let's say it lies perfectly on the tabletop here, like this. Okay, so you can see here. This is theta. Okay, let me tidy up the theta here. So this here is theta, is the angle here. Okay, and this is A. Well, let me tidy up the A here. So this is A. Okay, now if you draw a straight line, hang on. If you draw a straight line down here, like this here, okay, this will form a right angle triangle. See, so within this right angle triangle, if you draw a straight line down here, you will form another right angle triangle inside a right angle triangle, if you know what I mean. Now you can find out the height h of this thing here, just in terms of A and theta. So theta could be any angle. We don't care. Let's just call it theta. Now the adjacent of this triangle here, it could be any length. Let's just call it A. Now, if you want to know the hang on, let me tidy this up. So hang on. Yeah. So now if we draw a straight line down here, so this will be a right angle triangle. Okay. If you want to know h here, the height of this thing here, well, the height would be given by this. The C would be here. The sun would be here. Okay. So here we would need, well, we've got h to work with and A here. So it's going to be 10. Okay, hang on, bear with me, it will make sense later. So if we want to know the height h here, it will be 10. So tan the angle, which is theta, equals h over A. So we times both sides by A. It will be A tan theta equals h. So this height here, we can remove the height here and just write hang on, just write the height here is given by A tan theta. Okay, so notice here, well, it's in terms of A and in terms of theta here. So the height here we can just write as A tan theta. So no matter what A is or theta is, we can always put it into here to find out what h is. Okay, so now so we if we wanted to, we can work out the height of this thing. Now we can also work out the length of this thing just by knowing theta and A. Okay, so hang on, let's call this I don't know, let's call this y. So y is this length here. Now if you want to know y in terms of theta and A, remember we don't know what theta could be anything and A could be anything. But if you want to know y, well, here you would use this right angle triangle here. Last time we wanted to know the height here, so we had to use this triangle here. Okay, but now because we want to know y, we are going to use this right angle triangle. If you want to know this height here, well, you've got to use this right angle triangle here. Okay, so wait there. So this one here, we want to know y. Now y, well, because we're using this right angle here, this right angle triangle here, the C will be here like this, the sun will be here. So we want to know y, and so the hypotenuse is not in play here. So again, so this would be tan. Okay, so we know that tan theta equals y over a. Now we want to know what y is, so we times both sides by a. So a tan theta is y. Okay, so remember this, a tan theta. Okay, so this distance is a tan theta. So we can express this length here by recycling the theta and the a. Okay, if you want to know, we can express this height here in terms of theta and a as well. Now we can also express this length here. Okay, hang on. So let's split this down here again. Now we've got another triangle. Can you see that? It would be this triangle here. So by using our imagination and drawing a straight vertical line here, we managed to form three. Well, we've got three right-angled triangles. Well, anyway, hang on. Let's draw this vertical line down here and look at this angle here. Okay, we managed to find out the length of this thing by recycling the theta and the a. We managed to find out that this length here by recycling the a and the theta. Now we can actually work out this length here. Okay, hang on. I'm gonna show you. Hang on. So let's call this angle here. Well, actually, what is this angle here? Well, inside any right angle triangle, you know all the angles add up to 180 degrees. Okay. Yeah. Let's take my word for it. It's actually 180 degrees when you add up all three angles here. Okay. It comes to 180. Now, if you want to know this angle here, well, get 180. Take away this angle here, which is 90, and then take away theta. Okay, so this angle here is given by this whole thing here. Now, same entity, you can merge them. So 180 take away 90. So this is like your elephant, giraffe, because the two of these are the same entity. You can merge them together. So it's 90, 180 take away 90. They're all the same entity, so you can merge these two. This is your giraffe, so leave it alone. You can't merge this with these two. So anyway, it would be 90 take away theta. So this angle here is 90 take away theta. Okay, the reason the reason we know that is because all the angles inside a right angle triangle adds up to 180. Now 180 take away 90 here, and then take away theta here. So what's left is 90 take away theta. Okay, so now we know that this angle here is 90 take away theta. Remember, this exists in a bubble here. Okay, so the angle here is 90 take away theta. We are going to draw a straight. Well, we're going to imagine a straight line down here, and we've got ourselves a right angle triangle. Now earlier we worked this out to be what was this length here? It was a tan theta. Yeah. So this length here is a tan theta. Now we want to know. Let's call this x. Okay. So we could use this angle here. This angle here. We could leave it as 90 take away theta. That's what that angle is. So leave it as that, 90 take away theta. So now the sun would be here. Okay, the sea would be here. So if we want to find out x here, we're going to need a cod jumping out of the water. So x here, we are trying to find an expression for x in terms of theta and a. So anyway. So here you've got a cod jumping out, so it would be cos. Okay, so hang on, cos the angle, which is 90 take away theta. Okay, equals x over this length here. This length here is a tan theta. Okay. So now we want to get x on its own. So we remember this is just a number here. A is a number and tan theta is a number. So what we do, we times both sides by a tan theta. So it would be this. Hang on. It would inside your mind, times both sides by a tan theta. So it would be this. Take the cos down, cos 90, take away theta, and then times a tan theta. Hang on, a tan theta equals x. So x is this. Okay. But let's tidy up. Let's put this a here in front, because a is like a whole number. And well, anyway, put a in front, times cos 90, take away theta, close it, and then tan theta equals x. So x is basically this number here times this number here, and then times this number here. Okay. So we've worked out the length, this length here, just by recycling a here. See, a here, and theta. So that's all we need, a and theta here, to work out this length here. Okay. So hang on, just to recap, by just knowing a and theta, we can work out this length here, we can work out this length here, and we can actually work out this length here, and we can also find out the angle here. Okay.